Hello everyone, today we'll be starting a very important chapter, that is light. This chapter is important because of your examination, that is your IIT JEE. Also it's important because you are able to see anything because of light. On a lighter note, you are able to view these lectures because of light. So let's get on the serious mode now and let's see what is light. Is light a wave or is it a particle? Now there has been a lot of controversy regarding light and we'll discuss this before we proceed. Light was assumed to be a particle by the famous scientist Newton. He told that light is made of a series of particles of light. So when a light source, maybe a bulb, when it emits light, it actually emits particles of light. It emits particles. And then he explained the phenomena of reflection and refraction using his assumption of particle nature of light. He told that, well, light is a stream of particles. So when a stream of particles strike a surface, it undergoes an elastic collision. The particles undergoes elastic collision and then they are reflected. So since there is an elastic collision here, that's the reason why the angle of incidence is equal to the angle of reflection. This was his explanation for the property phenomena of reflection. He explained the phenomena of refraction using the property. He said that the denser medium has a tendency to attract the particles of light. Now, since the denser medium has a tendency to attract the particles of light, and that is the reason why when light moves from a rarer to a denser medium, the light particles bend towards the normal because they are attracted by the denser medium. So that was his explanation for the phenomena of reflection and refraction. So well, Newton was a very renowned figure that time, and so this theory was accepted and people accepted that light has a particle nature. Until what happened was, there was a guy or a scientist, famous scientist, Christian Huygens. He told, no wait, light is not a particle, it's a wave. And he explained the phenomena of rectilinear propagation of light using the fact that waves also travel in a straight line, right? He said that to us light appears to travel in straight line because for the light the wavelength is very small compared to the dimensions of the surrounding. So when light is traveling like this, it's actually a wave, but since the dimensions of the surrounding are very big compared to the wavelength of the light, so that's why light is assumed to be traveling in a straight line. So this was his explanation. But at that time, people or the scientific world had a lot of faith in Newton, so they gave more importance to his theory of particle nature, and people were a bit hesitant to believe in the wave theory given by Christian Huygens. What happened was, it was at that time when Thomas Young, another scientist, performed the famous double slit experiment. We'll discuss this experiment subsequently. So Thomas Young gave his double slit experiment. And at this time it happened was, this experiment couldn't be proved using the particle nature of light, or the particle nature of light failed to explain the double slit experiment. So this was a very serious issue at that time. What happened was, the double slit experiment, it was found that two light sources which are coherent, the light coming from the two coherent sources interferes and they produce maxima and minima. Remember, maxima, minima, interference are the properties of a wave. So it was found that light coming from two coherent sources interferes and they produce maxima and minima. This couldn't be explained using the particle nature of light, and subsequently the wave theory of light started gaining importance. After this, a lot of experiments were performed by Fresnel, Foucault, Maxwell, and ultimately that put an end to the wave, to the particle nature of light, and it was accepted that light is a wave. It was accepted that light is a wave. Okay. Now, that was not the end. After this, what happened was, another concept came into existence, the photoelectric effect. In brief, let me explain what is photoelectric effect. When light strikes the surface of a metal, electrons are ejected. That is photoelectric effect. We'll discuss that in detail in subsequent chapter. But the photoelectric effect couldn't be explained by the wave nature of light, and we had to go back to the particle nature to explain this photoelectric effect. So we went back to the place where we had started from. We had started from assuming light was a particle, we discarded it and we assumed that light was a wave, but then photoelectric effect couldn't be explained by the wave theory, and then it was accepted that particle theory is also important. Finally, the question is still open, and everyone has accepted that light has a dual nature. It is a wave and it is a particle. Whether light behaves as a wave or a particle depends on the surrounding or the situation. There are some phenomena which can be explained using the wave theory, like interference, diffraction. There is some theory which can be explained by the particle nature, like photoelectric effect. There are some generalized phenomena like reflection, refraction, which can be explained by both wave and particle theory. So in this chapter of optics, we'll first discuss the generalized phenomena like reflection, refraction in detail, and then we'll move on to wave optics, where we'll discuss the phenomena of interference, diffraction, and then we'll discuss in brief what is photoelectric effect to explain the particle nature of light. Okay, so that's the gist of the chapter. Now let's begin with the first topic, that is reflection.